Hello again. In this video, we are going to talk about the role of the electrophile for both an SN1 reaction and the SN2 reaction. All right, so I'm going to draw two different electrophiles, also called the substrate. So again, these are our electrophiles, or we could also call these substrates. And let's say they're going to eventually react with a nucleophile, but this is an SN1 process, so the leaving group is going to leave first. So remember, in an SN1 reaction, it's a first order reaction. So the leaving group leaves first, and then we end up with intermediates. So in reaction A, we would end up with a primary carbocation. And then we would still have our nucleophile, which has not reacted yet. And we'd have a leaving group that is negatively charged. Now in reaction B, we would end up with a tertiary carbocation. And then we also have a nucleophile and our leaving group. And then in the second step, the nucleophile attacks the carbocation. And we end up with our products. Okay, so the question I am interested in is which reaction is more likely to undergo SN1. So if you want to think about this for a minute, you can pause the video and then we will go over it together. Okay. So the only real difference here between these two reactions is the type of carbocation intermediate that we have. So in the first reaction, reaction A, we have a primary carbocation. In reaction B, we have a tertiary carbocation. So if you remember from chapter 6, tertiary carbocations are very stable. Why is that? So remember, tertiary carbocations are more stable than secondary carbocations, which are more stable than primary carbocations, which are more stable than methyl carbocations. And this is due to a keyword, hyperconjugation. So remember, if you have a carbon with a positive charge, that means it has an empty p orbital. And that p orbital can be stabilized by sp3 carbon, or sp3 hybridized carbons, through hyperconjugation. So the more sp3 carbons that are attached to the positively charged carbon, the more stabilized it is. So typically in reactions, we want to form more stable products or more stable intermediates even. So which reaction would be more likely to undergo SN1? B. So B is more likely to undergo SN1 because its intermediate is more stable. Okay, now there are some exceptions to this rule. So for instance, remember in chapter 6 we said that if something is resonance stabilized, then that's going to be more stable than something that has hyperconjugation. So let's look at some exceptions to our rule. All right, so at first glance, this molecule, or this ion, looks like a primary carbocation, right? However, it's attached to a benzene ring. So this benzylic cation is resonance stabilized. And therefore, it can undergo SN1. So again, remember if something is resonance stabilized, that's more stable than hyperconjugation. So even though this looks like a primary carbocation, because it's attached to that benzene ring, it can resonance stabilize. So it's actually a really stable intermediate. Now there's another exception, which is our allylic cation that we saw a long time ago. And this also looks like a primary carbocation. But remember, it can resonance stabilize. So this allylic cation is also resonance stabilized, which again is more stable than hyperconjugation. And therefore, it can undergo SN1 because it will still be a really stable intermediate due to that resonance stabilization. So if you do draw an SN1 reaction, double check if your intermediate has the ability to resonance stabilize. If it does, it might be even more stable than a tertiary carbocation. If it doesn't, then double check what type of carbocation it is. If it's tertiary, then it's more stable and it's more likely to go through SN1. Now, let's look at the role of the electrophile in an SN2 reaction. So we're going to draw those same reactants or electrophiles that we drew before. So remember, these are the electrophiles, or we can also call them substrates. And they're reacting with a nucleophile. Now, in an SN2 reaction, remember this is a one-step reaction, so everything happens in one step. So the nucleophile comes in, it attacks the carbon next to the leaving group leaves. All right, so then we end up with the same products we saw before. Oops, that should be our nucleophile that's attached. Okay, so which reaction is more likely to undergo SN2. Now, I'll give you a hint. Think about how bulky the substrate is. So if you would like to pause the video and think about this for a minute, you can, and then when you unpause, we'll go over it together. Okay. So remember, I gave you that hint to think about how bulky the substrate is. So in reaction A, that substrate or electrophile isn't too bulky. The nucleophile can very easily come in and attach to that carbon. But if we look at reaction B, there are methyl groups kind of in the way. And the nucleophile might have a hard time kind of wedging itself in to attack that carbon. So in this case, A is more likely to undergo SN2 because the electrophile is less bulky. Or another way to say this is it's less sterically hindered. So sterics refers to the arrangement of atoms in space. So in B, we have a ton of atoms, those methyl groups, that are hindering the nucleophilic attack. So that substrate is sterically hindered. All right, so just a quick note here. SN2 reactions will occur for less bulky reactants. So a general rule of thumb is if you have a tertiary carbon, like in reaction B, that is going to be the most bulky type of reactant, so it's the least likely to undergo SN2. So I'm not going to draw greater than or less than signs here. I'm just going to list the different types of reactants. Oh, I guess let me actually write this as CH4 since we don't have an intermediate in this reaction. So again, tertiary carbons are the most bulky, or they're the bulkiest, so they're least likely to go through SN2. And then a methane molecule is the least bulky, so it is most likely to undergo SN2. And then primary will be the next most likely SN2 reactant, followed by secondary, and then tertiary is the least likely. Okay, so now that we've talked about the role of the electrophile in both SN1 and SN2 reactions, in the next video, we're going to talk about stereochemistry for both SN1 and SN2 reactions. So I will see you then.